So my name's Chad Dize. I am the manager of design engineering at HT Robotics, and I worked on the Revolutionizing Prosthetics 2009 project for about 5 or 6 years. So what they ended up doing is they went with what was called the intrinsic version, which meant that all of the power, all of the motor systems, all of the gearboxes were all located within the hand structure. So my responsibility was with the hand was to kind of design how that system would work, and so there was a lot of pulley systems in there so that as the strings were pulled, it would actually curl down the fingers. The gain that you get from sensory feedback seemed to be limited unless you were in a situation where you couldn't see. Admittedly, this varied from person to person, and for our situation, the gain of getting sensory feedback was much more limited than the gain that you would get from, keeping it cheaper. But I will say from a prosthetic standpoint, they're always trying to get more sensory feedback and put it back in. The issue is that the sensors vastly exceed the ability to get that information back to the patient. Right now, you could buy an arm or a hand right now that has all the degrees of freedom, but if you can't do anything with it, what's the point of spending that much money? So once you have something that is, 20 degrees of freedom, how do you control that, and how do you understand, what the brain is doing? So, even in the time that I was there, they started with doing the myoelectric sockets, where what that was is they had little sensors on the inside of the socket, and as you moved your muscles, it could sense, and so you train it. So if you had the disarticulation right here, the remaining muscles, if you move them, your muscles still move even though there's nothing to move, and then it would sense that. It could learn, okay, this equals grasp, and then that's how you get the very simplest forms of grasp. And I think that that's the type of stuff that is just now starting to come onto the market a year or two ago, I would say. I think the Touch Bionics hand has a little bit of that, but judging from 5 years ago, where the best thing on the market could essentially close, that was about it. And so going from there, I think that you're just going to see more and more kind of degrees of freedom, but that's going to kind of lag behind whether or not you can control it. So it's interesting to see where it's going, but I think that the control system is really where you're going to see these leaps and bounds because, every 2 years your computing power is doubled. So who knows what they're going to do 10 years from now. What you have to keep in mind was a completely custom system that was intended to be state-of-the-art and then more. So every single component in that is custom. So this was never intended to be, well, never intended is not fair. It was not built to be a consumer product. If you wanted to just go out and buy the equivalent, it would start at about $350,000 and probably go up from there. That's not including the surgery. That's not including anything else. It's just the mechanical hardware. I would say that it would be even more expensive, but one thing you have to remember is that you can't buy this because it doesn't have FDA certification. I think you could probably get them down to about $250,000 as is, and then they could be significantly reduced. I mean, you have to keep in mind that the technology that was created in 2009, you could go out and your iPod is smarter than it now. So if you took that time and you kind of invested in making it less expensive, this same thing 10 years from now could be extremely affordable for the regular person. And so what they're trying to do is they're trying to use the top of the line right now with the neural feedback to kind of figure out how that would work, because the mechanical is about as good as it can get right now.